Hi everyone. So as promised, here's like my review of the homework. So if you had any trouble with the homework, you can go ahead, you can check and see how to do each problem. All right, so we were working on the Pythagorean theorem and we know that a squared plus b squared equals c squared, and we know that in a right triangle that a and b would have to be the legs and c would have to be the hypotenuse, and the hypotenuse is always across from the right angle. So I talked about the fact that you could find these right triangles in all different figures. So let's see how you did. All right, so for a rectangle, we always want to draw a picture of it. So I draw a rectangle. I know a rectangle is a quadrilateral or a parallelogram with four right angles. I'm actually going to just draw one in. And then it asks me to find the length of the diagonal. So I don't draw in both diagonals, I drew in one, because I only need part of it. So now you might see the right triangle. So this particular rectangle has a length of 6, a width of 8, and I want to find the diagonal. I'm going to call it D. I could call it C, whatever I really want to is fine. So I would do 8 squared plus 6 squared equals D squared. All right, now remember I have to do all of that, the squares and the addition before I can do anything else. So 8 squared is 64 plus 36 equals D squared. All right, now I add 64 and 36, I get 100. And then I have that square root with no linear terms, so I can use the square root method. I take the square root of both sides, and I get that D is equal to, remember, plus or minus 10, but because we're talking about a rectangle, that diagonal has to be 10. It can't be the negative length. All right, so that may have helped you if you were having trouble recognizing what the diagonal and where the right triangle was. Same thing with a square. Remember, a square is a parallelogram with four congruent sides and four right angles. So again, I only draw on the one right angle because I don't want to get too crazy on this. And it said that it has a side of 6. All right, well, if one side is 6, then the other side is 6 because it's a square. Draw on the diagonal. I'm going to call it D in this case. So 6 squared plus 6 squared equals D squared. Okay, so now we simplify. So we get 36 plus 36 equals D squared. And I add those together, which is 72 equals D squared. I take the square root of both sides, and now I have to simplify root 72 because these all need to be written, as I said in class, as exact values unless noted otherwise. All right, so remember I told you, cut the number in half and see if that's a perfect square. In this case, it is. So 36 times 2. Well, I hope you noticed that 36 plus 36 is the same thing as doing 36 times 2. You might have seen that. So this is the same as the square root of 36 times the square root of 2, which is 6 root 2. And so the length of my diagonal is 6 root 2. Okay, moving on. Oh, my favorite, the isosceles triangle. So the isosceles triangle we know is a triangle with two congruent sides. Okay. And it says, given an isosceles triangles with legs of 13, remember legs are the two congruent sides and a base of 10, find the length of an altitude. Ooh, vocab word from an earlier unit. Wow. So remember, an altitude is a line from a vertex going to the opposite side and is perpendicular to the opposite side. And in an isosceles triangle, it also cuts the base into two equal parts. So it wants us to find the length of the altitude. So I'm going to put an A right there. So now you may see that we have a right triangle right here and right here. We can use either one. So A squared plus 5 squared, that's important that we cut that in half. It wouldn't be 10 squared, equals 13 squared. Okay, so now we get A squared plus 25 equals 169. We subtract 25, and A squared equals 144. So A equals plus or minus 12. But in this case, it has to be 12 because we're talking about a length. So my answer, the altitude, is 12. Now you might notice now this triangle had whole number answers, 5, 12, and 13. So I'd like you to go back to your notes and the examples we did in class and see if you find any others that had those same exact side lengths. All right, and I'll go over that in class. All right, so then I gave you an isosceles trapezoid. Okay, so we need to fix this picture a little bit. So I want you to go ahead and I told you in class, make sure you put a right angle right here and right here. This one's harder because number one, this piece right here was the x, and I think some kids might not have seen that. So that's important. The whole length is x that we're trying to find. And I looked at this and I was like, well, if this is 10, this is actually a rectangle, right? Which makes this side 10. All right, and it's isosceles trapezoid, which makes these two equal. So I'm actually going to call them A. I'm going to put an A there and an A there, and I can use either one. Now, this triangle over here, you see we have two sides, and if we have two sides in a right triangle, we can find the third side using the Pythagorean theorem, as long as it's a right triangle. So this is what I have. All right, so I'm going to do 15 squared equals A squared plus 12 squared. Now I could have done A squared plus 12 squared equals 15 squared. It's the same thing. So 225 equals A squared plus 144. Now you can see now I'm really want you practicing these perfect squares so you know them. Okay, so I'm going to subtract 144. Okay. And let's see, that's going to give me 181 equals A squared. Take the square root of both sides. A is equal to plus or minus 9. We know it's going to then be 9. So this is 9, and this is 9, and this is 10. So we add them together to get x. So 9 plus 10 gives me 28. So x equals 28. Okay. All right, so those are some figures you could see it. So if you turn the page and go to question number 2. So number 1 you should be able to do. Number 2, the diagonals of a rhombus are 18 and 24. Find the length of each side of a rhombus. All right, so we need to recall some things about a rhombus. First of all, in any rhombus, the diagonals of a rhombus are perpendicular. And because it's a parallelogram, the diagonals bisect each other. Remember the properties of parallelograms. Those are important things that we're going to need for the rhombus. Now remember, a rhombus is a four-sided parallelogram with 4 congruent sides. It says the diagonals of the rhombus are 18 and 24, so watch. I'm going to draw in my diagonals. They are perpendicular to each other, so there's that right triangle I'm looking for. And they also bisect each other. So if one of the diagonals is 18, then each side would be 9 and 9. And if one of the diagonals is 24, then the other side would be 12 and 12. So now I have a right triangle. I have 4 of them, right? With a side length 9, a side length 12, and I want to find the length of each side of the rhombus. So I'm going to call it S, okay, for side. Now again, you can call it C. It doesn't matter. All right, so now I use the Pythagorean theorem, and I do 9 squared plus 12 squared equals S squared. Okay, so we get 81 plus 144 equals S squared. We add them together, we get 225 equals S squared. We take the square root of both sides, and we get S to be plus or minus 15. So in this case, it's going to be 15 because we're only looking at the positives. Again, a whole number answer, 9, 12, 15. Has that come up? Go back through the pages now. Has that come up at any other point? All right, so we came up earlier, we saw one that had 5, 12, and 13 as side lengths in the right triangle. And this one had 9, 12, and 15. We're going to be talking about those in class, so I really want to make sure you understand. Okay. If you go to the last page, page 9, you might know I threw in some review here, but it's still not all review because we need the Pythagorean theorem. All right, so it says find the area of the triangle to the nearest tenth of a meter. Right there, that tells me I can use my calculator. Okay, it's telling me I'm not going to get an exact value, which is fine. Okay, all right, but I see an isosceles triangle. I have to find h, because remember the area formula is base times height over 2, and an altitude, which is drawn in here, is a height. Okay, so the first thing I'm going to do is I'm going to split the base in half and make it 5 and 5. I'm going to do the Pythagorean theorem, so h squared plus 25 squared, or sorry, 5 squared, which is 25, equals 7 squared. So h squared plus 25 equals 49. Subtract 25 from both sides, and I get h squared equals 24. I take the square root of both sides, and I get h equals, I'm going to practice simplifying first. So this breaks into the square root of 4 and the square root of 6. So h is 2 root 6. Now watch, I'm going to simplify this whole thing before I put it into my calculator, because we only want to round at the end of the problem. We don't want to round more than once in the problem. So my base was 10, my height was 2 root 6, and this is divided by 2. So I'm now calculating the area. So I'm going to simplify. The 2's cancel because it's multiplication. I can do that. So I get 10 root 6. I'm going to put that into my calculator. Good practice for you. We're rounding to the nearest tenth. So the area is 24.5 meters squared. Okay, so now you're going to try it on the next problem. And I'm going to tell you that the answer comes out to be 56.2 meters squared. So that's your goal. All right, the last one. I'm just going to help you draw the figure. You're going to be given opportunities to use the Pythagorean theorem within word problems as well, so we're going to have to be able to draw them. So step 1, you place a 10-foot ladder against a wall. If the base of the ladder is 3 feet from the wall, how high up the wall does the ladder reach? So remember, with word problems, I expect you guys to write let statements, letting x equal our variable. So our x, we get our variable directly from what the question asks. So we're going to let x equal how high up the wall the ladder reaches. All right, so I have a wall. Okay, so this is my wall. And I have a ladder laying against it. It's being placed against the wall, and the ladder's 10 feet, so this is 10. That ladder is 3 feet from the base of the wall. Now, a wall and the ground are always going to create a right angle, and this is 3 feet because the ladder's placed on the ground 3 feet away. So it asks, what's the height of the ladder, right? How high up the wall does the ladder reach? The height of the wall from here to here. All right, so now use the Pythagorean theorem. X squared plus 3 squared equals 10 squared. So x squared plus 9 equals 100, right? And then we subtract 9 and we get x squared equals 91. We take the square root of both sides. And so x equals, it's a word problem. So right now I'm going to say you can use your calculator. We put that into our calculator and we get about 9.5 feet, okay? All right, so the ladder is going to go 9.5 feet up. Now the thing you need to be really careful about is, let's pretend we got an answer of, 12. If we got an answer of 12, you have to ask yourself, can that be the side length of a right triangle? Because remember, the hypotenuse always has to be the longest side. So if you got a number that wasn't less than 10, you did something wrong. It's a nice trick for you, okay? All right, so hopefully that explanation will help for those of you that had trouble with any of these homework problems, okay? Have a great night, guys.